So in number 11 in this section 8.2, we have the two equations y squared equals x plus 1 and y squared equals 3 minus x. And normally our equations are written in the form of y equals. So I'm just going to rearrange this a little bit so that we can kind of get an idea of what this thing looks like. So to get y by itself, I would say that y is equal to the square root of x plus 1. But when you take the square root, it could be a positive or it could be a negative. So I have to include that plus or minus. The same thing occurs here. So I have plus or minus, and then this is 3 minus x. Now, if you remember, a square root function is a parabola, is half a parabola on its side. It's opening this way. But this is going to be shifted 1 unit to the left. So what we have here, if we graph these, is this is shifted 1 unit to the left, going in this direction. And then we have the plus or minus. So that gives us the bottom half of this parabola. And then the 3 minus x, if x is 3, 1, 2, 3, then this is going to be shifted to the right 3. Okay, but let me phrase it this way. If x is 3, then y will be 0. Okay, and so what happens then is this guy opens to the left and the other one opens to the right. Now that we have an idea of what these things look like, I can set this up using a horizontal rectangle, and I'm going to integrate now with respect to y instead of x. My length of the rectangle is right minus left. And then I'm going to integrate from this y value, the y value of this point, to the y value of that point. And I'm going to integrate with respect to y. So now I'll take my take the calculator, and I'm going to graph the first equation, square root of x plus 1. So square root of x plus 1. And if I hit zoom 6, you can see there's that parabola on its side. And then the other one is the square root of 3 minus x graph. And now you can see that I have the top half of each one. And if I graph the bottom half, then it will just be underneath here. It's symmetric with respect to the x-axis. So now I need to find this point right here. So second trace, find the point of intersection. And this time, now I'm going to be integrating with respect to y. So instead of getting my x value, I'm going to choose my y value. And that turns out to be 1.4142. So I'm going to integrate to 1.4142, and because it's symmetric with respect to the x-axis, I know that the bottom would be 4.12. Now, if you want to verify that, you can graph the other parts of the parabolas, and you can actually verify that. Okay, now the next part's a little bit tricky because this parabola on its side, this parabola, comes from this equation. So if I rewrite that equation to get the x value, x is going to be equal to 3 minus y squared. Okay, and that is the right point of that of that rectangle here. So when I do right minus left, I know that this is my x value that corresponds with the right. Now, for the other equation, that's the parabola that is opening to the right. So now if I rewrite this equation, I get x is equal to y squared minus 1. And that gives me my left edge, the x value of the left edge of that rectangle. So now when I integrate, I still have the same limits of integration, but my right will be 3 minus y squared, and my left will be y squared minus 1. And I'm integrating with respect to y. Now, when I plug this into the calculator, I can't use y's here. I'm going to use x's. So let's see what we get then. I'm going to go to Math 9, and it would be 3 minus x squared, okay, minus x squared minus 1. And then I'm going to integrate now with respect to y, but my calculator, I'm tricking my calculator here. I'm going to integrate with respect to x using f and I and t, even though my variable here is y. And now I'm going to integrate from negative 1.4142, and then to 1.4142. And when I get that, I end up with 7 point. So this is 7.542. Now for number 12, we have a similar situation. We are given y squared is equal to x plus 3 and y equals 2x. Now we can streamline this just a little bit because what we have here is an equation similar to the one we had up in number 11, but this is going to be shifted 3 units to the left. So it's going to come like this, it's going to come like that, and then y equals 2x is a line that comes through here. So if I use horizontal rectangles again, then I can integrate with respect to y. And once again, I need my right x value and my left x value. Now, the right x value comes from this line, y equals 2x. So I'm going to rewrite that as x equals y over 2. So y over 2, this is my right edge. My left edge is from the parabola, and that's going to be y squared minus 3. I'm going to integrate with respect to y, and now I just need my limits of integration. The y value at the lower point to the y value at the upper point. Okay? So now I need to get this value, and I need to get that value. Now, when I do that, I know that I need the bottom half with that line. So let's see, this is going to be y equals 2x. And then the other one is the bottom half of that parabola. So that would be negative square root of x plus 3. X plus 3. And that will give me the bottom half of that parabola. And now when I hit zoom 6, we'll get that line, and then we get that parabola. Now I need the y value of that point, the y value. So If I hit second trace, 5, enter, 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 I will get my y value is negative 1.5. So I'm going to integrate from negative 1.5. And now I need to get the y value of where they intersect up there. So now I have the line already. I have this parabola, but I want the upper half. So I'm just going to delete that negative in front of that radical sign. And so when I graph this, now I'm getting the upper half of that parabola. And second trace, 5. And I get y equals 2. So now I have my limits of integration. And I have y over 2 minus y squared minus 3 here. And now I just have to plug that in to my calculator using FNINT. So math 9, and that will be x divided by 2 minus x squared minus 3, comma x, comma negative 1.5, comma 2. And when I do that, I get approximately 7.146. Okay? So to reiterate what's going on here is I need to get my right edge of the rectangle and the left edge. I need to get the right edge of the rectangle and the left edge. And in order to do that, I have to get x by itself in this equation and x by itself in the second equation. So that's right minus left. But since I'm integrating with respect to y, okay, the width of this rectangle here is delta y, and that translates as dy in my integral.